So we saw the conditional statements today in the morning. Like if you want to compare something, or if you want to just make some statements or make some conditions in your program, we just stay with the conditions over there. So we started with some of the operators what we have read till now, like for the equals, not equals, greater, lesser, or greater than equals to, or less than equals to, right? So these are the just the operators we did, right? And then we saw the flow control statements. So those were a part of the conditional statements in the Python. So you have if statement. I think no one is coming much more there. So we did for the if statement, else statement, and the elif statement. Okay. So we have three kinds of statement over there. So you can see all these things in the previous video I have uploaded there. Okay, you can see there it has. Uh, okay, that's there in your YouTube. Okay, in your particular playlist you will be finding out there. So if statements are the statement which will execute only if the conditions are true. Okay, so only if the conditions are true you will be getting your statement of execution of the if statement. So all the syntax is kind of you just put off the test expressions and then write the statements over there, right? Next, moving up, we just take it how example. Let's take word equals to Jacob, and then we did if the word is equals Jacob, we will be printing the word. That's it. Okay. So these are the examples you will be getting in the morning video. Not discussing those much. Moving ahead. So we have number less than zero. That's negative number, right? Then we deal with the else one, where is if one of the terms, that is your if statement becomes false, then you will be going to check for the another statement. Not for the checking of the another statement. You can say you will be dealing with the statements or the block of codes of the another statement, kind of the else statement. Okay. So particularly, what are these are conditions and these are the statements you are writing on. All right. These are your statements. If statement. Similarly, you will be having else statement. Okay. So like number is greater than zero or it is a positive, you'll be getting this, or else you will be getting a negative number, right? Similarly, we check for the elif statements. Now these statements will be executed only if your alright, only if your if become false, and this will be just a checking statement too, as kind or similar of an if statement, you can say, right? So there also we check some conditions, and remember else will not check any of the conditions anytime. All right, so you have a lot of else and if questions to work on. Then we just did with a library of Sympy. So we'll be focusing on the Sympy today. All right. So Sympy, particularly we say it as kind of Sympy, right? So Sympy is, you can say, used for. Let me just write it in your one also. So this is particularly just a library which will you can get to see the definitions. So it's a Python library for symbolic mathematics, and it aims to become a full-featured computer algebra system. All right. So CAS stands for, these are the short term you should memorize always. CAS stands for your computer algebra system, right? So there are the packages of algebra, ABC, or kind of all calculus and everything. So you click on that. There is loaded previously also. So there are some of the projects which you can do with the use of Sympy, and you can see some of the names have been written, like for the, see, for the geometric algebra it's algebra, and you will be seeing the project here. So this is the project. If you want to see the source codes and all the things, you'll be getting it here. Okay, so it says the repository has been moved. So these are the source codes you will be finding out there. So these are just of the geometric algebras, right? So straight moving about there. Okay. So this is particularly used for your, you can just say it's for mathematical purpose. So we'll be doing with these things. Okay. So let's say we have done the help of that, right? So just import these things. So I can write it as a kind of a SMPY or SSP, whatever I want, right? So making your importations of your modules, you can write as anything you want, right? Moving ahead now. Now this Sympy has a lot of thing to work. Like it's get to you can just find out if you write sp dot and just press on the tab. So you will be probably getting. Oh, it's not working. Just wait for a minute. Hmm. It's not working. All right. Okay. So see, there are a lot of things to. Okay, it works. I think. Yeah, getting all these things whether it is correct or not. See, in the morning we dealt with those things. Okay, we just imported the Sympy and it worked there. It's not. It's working here. It's no problem. See now, if you want to check a prime number or like for odd number or even number or let it be a prime number. So what you do is basically you just use the for concept there, right? The looping concept of that. So there are the modules or the libraries, as I said, which will be using the, which will be just enhancing your time shortage, right? So you can write like sp dot s prime and you can just directly check on of any particular. You can say on for any number is a prime number or not. So let's take for the 10. It says 10 is not a prime number. Similarly, you can just take on for the different kinds. So we are getting these things. These are not exactly the same. No problem. So you can check whether number is a prime or not. That's kind of. So it says it's a prime number. So in the morning, we just made a program short out to find the number, whether a number is a prime number or not from the users. So we did it like kind of this. So we just taken users number that can be a prime number, right? So we just take an input from a user and that can be an integer. So it's enter a number and then we just take it if the speed is prime of the number PR, which will be equals to true. So if it is true, we'll be going for printing PR is a prime number. Okay. So you guys, I think you are compatible with this if and else. So not going much of the if and else. So if you're not, you can just go on by looking on for the videos. So there you'll be getting all these things, right? So Sympy is a very huge library to work on, guys. A very huge one. So probably it will take today or tomorrow, both the days, I think. Okay, yeah. So PR, you just give it's kind of a true, and if it is a true statement, like this coming as a true or not, so it's a prime number, and similarly not. So let's give an input from the user. Let's take it's 56. So it is a non-prime number. Similarly, you can take for a prime number too. So that will work as kind. Let's take 23. Yeah, it's a prime number. Okay. So these are the things. So when we define the Sympy, what we'll write it as? So today our module is to learn Sympy. Or you can write Sympy in Python. Okay. So when you come to define this, what you'll write as that it's a Python library for symbolic mathematics. You can write. Okay. So Sympy is a you can just call it as a Python library for symbolic mathematics. That's all, right? So you can call it as like, so you get a general definition by writing a help and all these things, right? So yeah, moving ahead. So just writing as this line of sentence, right? So first thing is you can just import it by writing import Sympy, and you will be getting it through importations of all these things, right? Then you then just check the prime or write all these things, right? I'm not discussing about much. So the Sympy is used in some of the areas. If I write the areas there, so areas it is used in are basically the you can say for the polynomials. What areas you can work with these things? You can work in the polynomials. All right. You can just go with the calculus while doing these calculations. So these are very much important in the statistics part. Okay. Because you will be applying, you should have a knowledge of these things while doing statistics too. So that is because this will be also helpful in your algorithms when you do, because in algorithms you need to write the formulas, and that will help you here there also, right? And meanwhile it is also used for the geometry, for the statistics, and many much are there. I'm not discussing everything. Okay, so there are a lot of things to write there, these works there. So the first thing is you can install it by just writing. If I go with the installation part, if you are working in the Anaconda, so installation is not needed there. That will be just pip install. There you just import it; it will be installed automatically there. Okay. So most of the cases, those who are working in the ideally and they install it like pip install Sympy, right? And then after that, they can just get it for that. Okay. So we did it as an importations to our file, right? So now you can just also check out the just the Sympy version, whether you are what version you are having. So we'll get to find out the so when we learn NumPy, it's kind of again a mathematics tool. So we're working on those two, right? Moving ahead. So see, just for printing my I'll again import it. So you can find it as a kind of sp underscore underscore version underscore underscore and so on, right? So when you run this, you will be getting a Sympy version of 1.5.1. I'm having this one. You can get your ones too, right? So these are the basic things, right? Now symbolic computation refers as a kind of a development to the algorithms for manipulating the mathematical expressions or mathematical objects, right? So we can find these things with the use of mathematics tool or the library math module. You have dealt with the math module, right? So let me see, you guys are, the video is here, the title is here, let me write it down. This is much. Okay. So you all know about the math module, right? So if anyone does not know, I'll just bringing up a quick sum of math module, so you will get to understand everything. Okay, so just summing up the math module again. So let it be So for those who don't know, for the math module, we'll just sum up here. So we'll sum up of the kind. Just I'm not going with the definitions and all. If you want for the math module, I'll make a separate video, and also in the data science, I think in the data science part, we have did right. So we have did in the AIML or in the data science, in which batch I have dealt with the math module. I think it's in the data science. I think Adarsh is not in the AIML. Yukta, I did in your batch or in Vamsi in your batch. Data science. All right, fine. So data science, I'll give you that video of that data science where we did with the math module. Okay. So just summing up with the math module there, and okay. So when you want this I'm writing what we have there in the math one. So we just import the math, and I'll writing it as M. Okay. So I'll take my math as my M. Now there are several steps to just focus on for writing. Suppose I'm writing a seal and then of 1.03. So this will probably return you the smallest integer, but the less than of the number. All right. So this is smallest number, but you will be not getting integer less than of the number. Similarly, you will be having m dot sqrt for finding out the square root of a number, and you can write anything. Let's say 81.0. So you'll be getting the square root. Similarly, we have exp of the argument. You'll be getting the exponential or the natural logarithm value there. Suppose you write 2.0, so you'll be getting e to the power of 2. So that's e to the power of 2. Similarly, we have fabs over we dealt with the fabs one. There you find actually the absolute value of the number. Let's suppose it's minus 45.2. So you'll be getting the absolute value there. Okay. So same as these questions will be asked in the Microsoft examination. Okay. So you can get to it very clearly. Right. Let's take any number of 23, and in the flow part you will be getting a number, or it basically returns you the largest integer but not the greater than the number. So when you deal with it, so largest integer, if you write it as, let's take any number for the float, and so I'll be getting it like that. Okay, so like this, there are a lot of things to explore in the maths. Okay, so you can get the probably the video from that. Suppose now in the math, if I write a math dot, or if I write m dot sqrt, let me import it again. Suppose I am writing math dot the sqrt of some particular number, and then the math dot again the sqrt of some other number, let's say 7. Alright, so we are getting the square roots of 25 as 5.0 and the 7 as 2.64, something like that, right? Similarly, we can get these from the Sympy module too. So if we write it as, if we write as import Sympy and then Sympy dot the sqrt. So there also you can find the square root. So you have the square root here also. Let's take 25 and just write the square root. So run this. All right, there might be some problems. Yeah, okay. So what you did it here. So as you can see now, the square root of 7 is calculated approximately like for the sqrt of 7, right? So here it is just like that. But in the square roots of the numbers which are not the perfect square are left like that. It's exactly. So if it is not a perfect square, so it will be like the square root of 7, not anything else, right? So if you write it a kind of Sympy, and then if you find the square root sqrt, Let's take any non-perfect square. Let's take a 23. So you will be getting as kind of these things, right? So just a symbolic representation you will be getting. So you can just write up that as all those things, right? So similarly, it's simply. So if you write just a whole square, then you will be getting a square root. So if you don't write the whole square, then you will be probably getting a square, just a kind of. Let's take it for 101. So that will say you can see the symbolic representation, right? So that's exactly as a kind of symbolic representation you get in the just a you can say the Sympy one, right? So Sympy code when you run these in the Jupyter notebook, so it's make up just a MathJax library to render some mathematical symbols in the form of a latex. These are the symbols form you get in the latex forms, right? So if I write it's kind of from the Sympy. So when you write a perfect square, you will be getting the output, and non-perfect square will be giving these values. So you can just show math as your mathmal code or anything. You can just get see your mathmal code will be like kind of this. So that's a easy one to work on. You can get a lot of things, math settings, your zoom the trigger or anything you can just work on. I will be sharing you all these things. So math DAX will be kind of what I am doing now. So from this Sympy, I'll be importing this star, which will be just used for the matrix, and then you can write your symbol. Your exponent as integrate. Where is integrate? Here, and write it as x dx. And then the dx dr. So a model object is not callable. Again, it's a problem here. Might be of the capital S. Alright. So if you write just a statement over here, what I'm trying to do is I'm just calling out the integrate function basically. So I'll be getting an integral of x to the power of x dx similarly, right? So just to work on the symbolic structures of the mathematics function, so you'll be dealing with all those things, right? So you can also just write on just a kind of, let's say you want to make some integration of or integral of where it is, yeah. So that depends on the differentiation or whatever you want. So you want difference or differentiate or integrations, anything. Okay. Similarly, let's take an integral. So when you write a integrals of x to the power of x and on the base of, let's take for the y. Y is not defined here, so we'll write for the x. So again, no modules is working on. This should work. Again, I think it's might be off. Yeah, you can see it's similarly the same. Okay, so that depends on how you write your codes. So there are a lot of things. So let's say if I work with the packages of the float or like for the rational numbers or kind of a decimal numbers. So there you write from the Sympy, you import your float, and then you can just find out the float of, let's say 8.56, any particular number. So what you are getting, what this class represents a floating point number for you, right? Okay, so these are just a floating point number you will be getting. If it is float, you will be getting a float. So if you write as a float of 20, so you'll be getting it's 20.0. These are the basics you have done till now, right? Now if you want to find a scientific notation, if I want to find a float of a scientific notation, so I'll be writing it as a float, and then you can just pass on this one point, any value, let it be e and 5. Okay, so what this stands for, so while converting, it's also possible to specify a number for you for the precision you can get it. So if you run this, you'll be getting it probably like these things. All right, so these are the scientific notation, or like you can just convert any integer to float, or the other things you can do with the Sympy, right? So you can convert, like if you want it to be first decimal places, you want only the first decimal places of the float. So let me write it as I want that 1 point, or the value of pi is 3.14, right? See, I want 3.14 and I give it by 2. So I'll be getting probably only 3.1. That is from the 2, I just want only 1. So that depends on what you write. If you write your 3, you'll be getting your 3.14 and like that. Okay. So there you go. So these are the things. Now if you want a symbolic representations in the kind of a rational number you want to add on, suppose you are writing suppose you are just writing a rational of, let's take any value, writing 1 by 2 plus the rational 1 by 2. You want to represent this, so this particular is 1, right? So if you want to represent a 3 of 2, so you'll be getting a rational of just 2. Okay, that's fine. So let's take 3 of 5. So there you'll be getting some rational values like these things, right? So just represent the rational of 1 by 2, you'll be getting it's kind of a 1 by 2. So if you want to represent a rational. Yes, anyone there speaking out? Yes, Adesh?
Sir, can you repeat that cell number 30? Cell number 30.
30? Where is 30? It's 31.
No, 28. That E5 one.
That's a kind of a scientific notation. You have read the scientific notation? It's E 10 to the power of 5 or something like that. So 1.33 into 10 to the power. Okay, let me open my calculator. Where I have it. See. So probably this is the calendar. Where is the calculator? Yeah. Fine. So I want 1.33 into, I'm writing 10 to the, just the power 1 multiplied by scientific is something like you are writing e to the power of x. Now that can be just your e to the power of whatever you write. So let it be e to the power of that. There I am writing about it's kind of 1.33 into 10 to the power of 5 exponent, right? Understood? So if you multiply it, or let it be 1.33 into 5 zeros. If I write it like that, let's see what comes. So probably get these values. Understood? Okay. Understood or not?
Yes, sir. Yes, sir.
Right?
Yes, sir.
So that's a scientific notation that is, okay, let me write here, it might be.
Sir, and then,
So
sir, and then cell number 31, sir, that 3.14, 2
into 10 to the power of 5. This is 1.33 into E stands for 10 to the base. Your exponent scientific notation is something like the x into the number into 10 to the power of 5, x into 10 to the power of x, anyone, y, what you want. So scientific notification particularly stands like for x into your 10, and then you just give a power of y, and then you will specifying your x and y over there. Yeah, so 31 was like you are just writing float. Okay, so you just give the precision of your output basically. So you write 3.14 and then write 2. So it will take only 3 and only 1. So if you write 3, so it will take 3 digits. Okay, so understand it like that. Okay, don't go with the big confusions. So So if you're writing 2, only 2 of them will be printed out from the starting. If you're writing 3, only 3 of the digits will be printed from the starting. Understand like that. Okay?
Okay, sir. Okay.
Alright, so a representation of a rational number can be done in the form of p by q. We know p by q is something like, you can get, okay, the p is not given, q is not given. So p by q is a kind of, let's give q number as uh, so that can be given as a kind of p by q, which will be kind of a rational of 2 by 3. So probably instead of writing all these, just write it 2 by 3 and you'll be getting a rational. Why it's so? Alright, let's take it 3 by 2. So that's fine. So these are the things you get the rational class while the p or q basically not being the 0, right? So if you write a floating number decimal point, you will be getting a rational of that too. So if you write as a kind of rational of, let's say, 0.2, so you'll be getting at there. These the rational numbers of those. So for a simpler representation, you can specify your denominator limitation also. Like if you're writing a rational, if you're writing a rational of, let's say, 0.23 and you want your limitations of your denominator, so you can define it like, okay, let me write it out. So you can limit your denominator, let's say by 100. So when you run this, you will be probably saying by it's 23 upon 100 exactly, right? So that depends. If you don't apply these, what you will get, it's kind of something like this, right? So if you define your codes over there, so if you write it's kind of 10, so this will run like the limit. Okay, this will say that is it, it's the value will be just 2 by 9. Okay.
Sir,
Yes.
sir, is Python treating all this as a data type or just symbolic representation? Like if we write x equals to rational of 0.2, the value returned to the x will be treated as a value or just a representation?
So you want x equals to, let's take 3 by 2, right? X. Got it?
So, sir, we can work with these values or just these are representations used for representation purposes?
No, you can work with these things.
Okay, sir. Thank you.
So you can just try, if you want to make a symbolic representation of a formula here, you can write for that. You can get to the power of all these things, right? For the, or something to the raise of the power or like that thing. Okay. So this is probably very much helpful in the statistic part. Why I'm dealing with this library? Because when you will be going in with the machine learning models, sometimes it may be needed that you want to do some bit of calculations. So there you will be using some formulas. Now for representing those formulas, I'll be writing it here in and you will be getting a formula, good formula here in front of you, right? So and in the statistics part, when we will go to the mean, median, LMS, RMS, there are a lot of things in the mean square error, a lot of things to do in the statistics. So there we also using these things, right? So let's move on. So now let's take a rational object kind of thing, and you define your numerator and the denominator as the strings one. So let's take it as a equals to rational and let it be 3 and 5. Just printing out a, so we'll be getting a 3 by 5, right? We'll be getting it kind of a 3 upon the not upon, it's 3 by 5. Now if you print on, then print it like a numerator and write it as the denominator as DE. So there again, I'll be using just a format method of a string. So these are the basics. So for getting off the basics, guys, what you do, you just work and see on the Python basics videos. So that you will be getting in your everyday in your playlist. And for just getting an advanced one, I just combine your both batches of AIML and data science till we just go on with the mathematics part. Okay, because these are same for you all. Okay, so I'll be treating of for one time in the evening and then in the afternoon. That's combining it's better. So it's a format of now you will be writing what you want the P and Q form. So it's rational number is something called the P and Q form. So it's A dot the P. So that is particularly your see the numerator part P by Q. Then you want the A dot Q. Understood? A dot the Q. So that is said to be your the numerator and the denominator. So you'll be getting your numerator as the 3 and the denominator as the 5. So you can get it. Okay? Understood? Now you if simply you print your A, you'll be getting a 3 by 5. Similarly like that. So as much we have seen is a kind of a float or all these things. Similarly, we can just write on for the integer and you will be getting for the integer. Let's say you want an integer of 100 point, let's say for 7.2. So we're getting an integer value that is right. So these are. Now the Sympy has a real number class that acts as a alias or from the float or all these, right? So we define 0 and 1 particularly as the singleton classes accessible for the zeros. So let me discuss for those things. So let's say if I write s dot the 0. So that's the exactly 0. Now the if you write the s dot 1, so you will be getting 1. So other predefined singleton numbers like you want half or you want some non-values or you want infinity there. So how to write all these things? Therefore, defining all those for the singleton classes we call as okay. So if I want the just kind of in half, so I'll be just writing it s dot half. So you'll be getting a half over there. Now you want the infinity. So you will import. You will be importing the infinity module there. That is OO. That's all. And why it is not? Oh, sorry. So you'll be importing these. And if you write just print your OO, you'll be getting an infinite sign there. Okay. So these are the things you just do in. Apart from this, you can just write it for infinity. And you can just there is some sorry the cases error, so you can also get the infinity from here. Okay, these are the things you just get it. Now in the complex error the complex type we have read case. Yes, Vamsi is saying something I think.
Sir, can you please clear me of two errors every time I'm getting this? Module object is not callable and rational is not defined. Where I would have made mistake. Every time I'm facing these two errors only.
So maybe you because of the cases, small letter or capital letter. Because give me the snapshot or write the code here in the just the meet one box.
Yeah, I'll get you the snapshot, sir.
Okay. So
Yes,
similarly, in the what we saw in the complex one, that if we write a complex number, let's say again the basics one, that's let's take it for 7j. So here, if I want to see the real part and the imaginary part, I was using it like 3.0 and 7.0, right? So similarly, when an imaginary unit number you want, you can just import it like for the I symbol, right? And it can be accessed using s dot imaginary unit if you want. That represent a square root of -1 basically. So -1 square root is I, you get it. Okay, so you can get it for if you want an imaginary. So you'll be writing. Vamsi has sent something. Just wait on. Rational of 1 by 2 plus rational is not defined. So do one thing. Write from simply
yes,
import rational. Write it like that. If you are getting an error, write it like that. You will be. I think you will be just work on with this. Write it like this and then run. See what comes.
yes, sir.
the next one is A equals to str of A. Str is not callable? How it can?
Sir, every time I'm getting that error.
Every time. Str is not callable. How? Okay. Okay, I will go with the str1 after the class. We'll see. First, let's complete this Sympy one.
Yes, sir.
Okay, we'll see that in a
Yes, sir.
minute. Don't worry.
Yes, sir.
Okay, you write this statement. See whether it's working or not.
Yes, sir. I will do that, sir.
Okay. So yep, moving ahead. So I was talking for the imaginary unit. So you can write it like. Okay, I also need to import the imaginary unit. So you just want to write it from the Sympy. You just want to import I. That's all, right? Just do it, and then you can just print on I, and you will be seeing it's a kind of iota. We say, right? Remember, guys, you read in the class that iota, under root of -1, and all these things, right? So we're doing with those things. So it's s dot infinity. You will be getting your iota over there, right? So you can also write it kind of an s dot the infinity. Again, you'll be getting an infinite value particular from there, right? So if you want an imaginary unit from there, so you can write as imaginary unit. So you'll be getting as iota over there. So you can also find the square root of these iota as find if you go with the square root method. So if you can write it from the Sympy, or let it be Sympy dot the sqrt. So you can just find out the square root. Now let's take I want a square root of -1. Okay, I want a square root of -1. So I'll be getting I over there. Understood? So there. And if I write it kind of, let's say I'm storing these particular one. Yeah, okay, where it is there. Let's say I'm storing these things in C, and my C is particularly the I. So if I write C multiplied by C is my -1. Understood? So this is you get to the basic mathematics. Okay, we dealt with all these things in class 11th and 12th. So we are just focusing on that. Okay, so these are the basics, right? So moving ahead, we'll see the representation of a just a kind of an expression. Expression, you understand expression? What is there in the expression? Like x square plus y square, a square plus b square plus 2ab, and all these things, right? Understood, no? So symbols is the most important class in a very simple library. Okay, so like for symbol, what you do is, no, let me write it for. So symbol is a kind of thing you just go to understand for getting for the polynomials representation or quadratic equation representation and all those things, right? So you will just writing it as for the Sympy. You will be importing out the symbol. All right, and then yeah. So now let's suppose I want to print now x square plus y square. Okay, I want to print the x square plus y square. What I'll do, I'll be just using the basic things. Again, I'll be writing my x equals to a symbol, and that is x. Okay, and similarly, I'll be taking y is my symbol, and this is y. That's all. Okay, you have defined these as this. Now you want your expression. You want your expression to be x to the power of 2 plus y to the, or let it be x square minus y square. So x square minus y square. Now you want your expression to be something like this. Now when you print your expression, you will be getting an expression over there, that is x square minus y square. Exactly. Understood, guys? Now that can be just taken off for various factors. If you want any particular things to be, alright, you can also define your xy as just a kind of a symbol. Okay, let's take it below there. You can just write xy as your symbol, and there you represent it as xy, right? That is xy. Now if you write, my expression would be square. So you'll be getting your expr as your x square plus y square plus 2xy plus y square. Isn't that interesting, guys? So these are the basic mathematics you are just importing in your with the help of a library or a module, you can say, on the programming section, right? So Pooja, have you done the Java, right? You have done Java also, I think.
Yes, sir.
Okay. So did you once again, sir, for Sympy, is it enough to import the module and use it methods? Yes, it's enough. So tell him to better post it in the group. Okay, someone has posted something in the group. Yeah. So I was asking to Pooja that uh, was or is these things possible to just go with a single line of codes in Java? So have you done it there in the Java?
No, sir. No, sir. We had to like pass the values, check for the expressions,
Yeah.
make the expressions, and that's. So I was asking if you have told that expression, you have printed the expression. So can we pass the values in that XY symbol?
So you want
Mane-
to pass on the values.
Yeah, but we are treating this as a symbol, right? So can we pass the values for xy? Can we input the values and pass any values to that xy? Because I am just confused that if we are treating as a string or just a representation thing.
There you will getting it. Let's see what comes. You will have to specify. You can see the values. Let me write it as. You can see my
Yes, sir.
2, 3, 6, and so on. Fine.
Yes, sir.
All right. Fine. So these things are possible. That's why I consider most of these students just ask me, sir, is this Java is better? So probably I'm not a Java programmer. I'm a Python programmer. So always I say Python. And there are a lot of things why I say Python. So this is just one of the library I'm talking about. Okay. Similarly, in the NumPy in Java, let's just say it kind just you want to find numbers. Let's just hope a situation. Now you are Java programmer, so I am asking to you. Just take that I want to print 100 numbers between 0.1, not 100, I'm saying I want to print some 200 numbers from 0.1 to 0.001. I want 200 numbers between them. Can you print it there? I want just 200 numbers between these two values. Yes, I'm asking to the Pooja.
Sir, maybe I'm not aware of that actually.
Okay, that's fine, no problem. So these can be done with just a couple of code in the NumPy. Just you take it's a kind of an NP, and then you pass with this that NP dot. You just want a linear spacing of these numbers particularly, and then you print it, and you will get the 200 numbers from all these values. And then you can just pass it on how much you want, or just let me write I want 200 numbers, so I'll be getting some 200 numbers from my 0.1 to all these things. So that is called a data you generate inside your Python, and that is why it is very much familiar. So see what I've done, just one particular line, and that's all. This is why I consider most of the guys to learn Python and just explore it there. Okay, but that is a very good thing to just explore on, right? Okay, so these are the things we'll be dealing NumPy. Don't worry, we'll be having NumPy session also. So let's go with the SciPy now. So isn't it interesting, guys? Learning, okay, you just compare the things. Learning Java was interesting or learning Python is interesting? Okay, say the truth, right? Don't say like learning Python, so Python is good. Say the truth. What is interesting for you?
So Python has got many features related to Java, but the thing is, we have to deal with many library functions. So
Yeah.
it is a bit tough to remember all the library functions. Sometimes it gets messed up.
Yeah, it is quite difficult to just remember everything. That basically comes when you just practice on everything, and then it comes like a everyday habit of like a bread and butter for you guys to just print on the codes. Okay, I have been practicing over. If I say it's like for I practice all these things just only let's say from the September and December. Or I practiced in the when I started Python learning. I practice it with the uh, um, August, September, October, November, and December. That's all. Those months, only those months. That's all. So with those months of practice, exactly I was working in the practice session. I just started to work with the evening because in the morning I was having colleges. So I just started practicing with the 4 p.m. and it goes till 2 a.m. in the morning, and that was my practice session from 4 to 2 in the morning, and then I sleep on. Okay, because I go to college also. So that was a practice session for all the days of the just August, September, October, and all those things. Okay, so that came as a practice session for me, and I mean, like when you practice all the time for these things, just for a limited time. So when it comes with a practice session of a regularization for some 2 to 3 months, it will just be a kind of a storage in your brain, and that will not go from anywhere from there. Okay, because that a hard disk in your brain, and it will not be vanished out. So you can work with the libraries just a practice, and it will be stored in your brain. That's all. Okay. Now let's see. A square is having a side. Let's say a square is there is a square or there is a
So,
yeah.
so did you use any online platform like HackerRank or CodeShape to practice all these things, or
No,
just
no, no, no. Students ask me. I just still I don't know what is there interesting in the hacker on and hacker rank of all those things. I never just visited all those sites. Many students say, "Sir, this is a question I got there." So I just okay, that's fine. You just deal with this and it will be practice. Then I asked them from where did you got this question? So saying that it's from hacker rank. What is this there? So I don't know exactly what is these things just going up because they get the similar questions. Yeah, for better than hacker rank, I suggest you if you go to the data camp questions, right? So I had been a trainer there too. So in the data camp, you can get all these things very beneficial, right? Because data camp makes exactly the same questions, bring out the exactly same questions as compared to the uh, just the interview questions of the big companies like for the IBM, Microsoft, or Amazon, or any other companies, right? They get you for every libraries. You have a lot of questions in the data camp. Uh, that I know, but for the hacker rank and hackathon, I don't know. I have visited their websites now. I have seen the questions because students say that sir, we get these questions. These are the types. So I visited to see how the questions there. So I didn't use any online platform. You have a student here in your data science. You have one student uh, there. It's Yukta Sai. She is my college mate, and we went for a training of the Python in the same. That was when I started learning Python. We went for the same in the IIT Bhilai. IIT Bhilai, and our trainer was Shubham Agrawal. He came from the Delhi, and he just taught up us a 2 day session of 16 hours. Yes, I didn't just went off for the online. That was all just of the practice. Okay, so you can also practice. It's not to worry on much. Okay, let's focus on this Sympy. We'll have talking much on later. So now let's take there is a side. Let's say that the square is of side 4 centimeter. Let's take a side is having 4. Now I want to represent it, or if I want to find a side cube, a side square, a side to the power of 4, anything, right? So a symbolic representation instead of just getting you can say, even if the number is not there in a particular variable, if it is a non or none value, so how to represent those? So you can write it as kind of symbol, and then you can represent it just your s or side. So there is an, okay, sorry. So you should represent let's say I'm writing it for side. Yeah, that's okay. Fine. Now this is a kind of a symbol. I'm always when you make a symbol, you just represent it inside a string because it will not take anything else from that. Okay. See in the there. Let's make it for 10. Okay. Now you can see here we have used the string. We have used a string here over also. So you can work with those. Now let's take 3 and if we run this, we'll get a side cube over there. That exactly you get in your side. Let's take a side square. That's an area of a square, right? That is a side square. So that is things you will be getting on. Now let's move forward and let's see if we want to print just a sine, cos, and everything for that. All those things what you're using on, right? So 1 second. Yeah. So before going to these, let's deal with these Sympy modules. Alright. So Sympy, as I said, have symbols that have multiple symbols at a time too, multiple values at a time which can hold. So if I write this from the Sympy, and if I import the symbols, and I write multiple symbols value, let's say x, y, and z as my symbols, and that is my symbols now. I'm writing as s, y, s symbols, right? Symbols, and you can write as x as y and z. That's all. Now, if I run this, you'll be getting just probably a symbols over there. That is x, y, and z. So these are, you can assign multiple values at a time, right? So you can write it for. Now, if I write from my Sympy, the ABC, I'll be importing the x, y, and z. So I have created x, y, z. I'll be just importing these things, right? So there are things. However, this cosine and cosine basically the cos function. Okay. So the names of the cosine or q are some kind of the predefined symbols basically. Okay. But the symbols with more than one alphabets or just are kind of not defined in ABC module. If you see the Sympy.abc, who's coming now. So you can find it's a library over there if I find it. So you can find some of the predefined characters over there, like for Q or R. If you want the R, so if you want R to be printed out, you can just write ABC, the alphabets of R or all these things. So these are some of the predefined you can just work on. Okay, so if you want any letter over there to print it out from the ABC, and that depends what you want. That you want alpha, so you're running there, you'll be getting alpha over there. Okay, so there are a lot of things. Let's say let's say Sympy dot the ABC dot your not that depends you non beta, you want delta, your division, epsilon or anything. Let's say bring the epsilon value. So we'll be getting epsilon value. Okay, I think someone has came. So there are a lot of things, and it's not easy to just memorize everything in just one particular day. That's why I take the morning session, and you have all the night and the morning too till the 8 or 10. Okay, you can practice till there. So basically, it's just a training session, so you will get to understand a lot of things at a time of the 40-hour session, and then you have whole life to practice on, right? So there. So similarly, you have a lot of things to do. Okay, so let's bring now the sine or trigonometric equations, you can say. So I can what I mean to say is that in the case of alpha or everything, there are some of the letters or alphabets which are predefined in the modules. Let's take it Sympy.abc. So there are A, B, C, small a, small b, C, D, E, F, G, H, Greek letters, kappa, lambda, and everything. You will be getting everything there, the symbol, string, or epsilon, everything is there, right? So from these things, let me bring. Okay, is there the T? All right. So from there, let me bring the theta. And just bring the theta and the gamma. All right, from there I'm bringing out my theta and gamma, and let's make an expression, and let it be a sine of the theta multiplied the sine, because see, sine square theta is not the sine into theta square, right? It's sine theta into sine theta. Most of the time a student makes mistake there also. So that's a basic thing you read in the class 10, right? So sine theta plus sine theta, it's sine theta multiplied by sine theta. Sometimes students, I say, find the sine square theta, so they do like sine into theta, and then they make a square of that, and they say, sir, this is sine square theta value, and I see where from that the values came. All right, so it's sine theta into sine theta, right? Now let's take for the cos one similar. So if you want to just get an expression of this, or just want to print this, so if you write xpr, so you'll be getting a sine square theta plus cos square theta. There is some problem, I think, or sorry. So you'll be getting your sine square theta and the cos square theta, right? That depends on anything you can take on. That's not a problem. Okay. So these are the things you'll be getting on, right? So if I write it as expr, so for now, the code can be given as kind of a snippet you want. If you kind of just subsets, you can say kind of the theta in place you want anything else. Let's say gamma. So that can be given in place of a gamma over there. So if you want to write in the place of theta, if you want these equations to be over or replaced by the gamma, use subs. That's the guide. Okay, so there you will be getting a gamma over there. That depends on whatever you write, you will be getting over there. Okay, so if you want to give a value over there, if you have an expression, let's say you have an expression of so let's take this one, this where it is. Yes, there it is. Now let's print these, copy, and so you have probably these. Y I'm having, XY is having 12, right? So let's just hope on that you have X and Y now. You have X and Y now, and you are giving X and Y the values. Let's say 2 and 5. You have given the values of X and Y to the 2 and 5 now, right? So your x square plus y square will be typically these values, right? If you remove these things, the values will be these plus 2xy, sorry. So your values will be this particularly, right? Now let's say you have an expression that is a, if I write it as theta square, so that will be represented as theta square. Similarly, if I write theta square plus theta, let it be theta, or let it be anything, let's say a square. Okay, so let's say a square and a cube. So this is a cube plus a square. Now let's say I want this expression to be okay, let it be there. Let's say I want this expression to be replaced by something different. That's what I am saying about. I want this a to be replaced by the y. So I'll be writing it. Okay, that subs. Where the errors are coming on the subs of a and 6y. Invalid syntax it's saying on. That is a correct one. It's invalid. Alright. So that exactly is same as I have done in the subs of that. We'll replace your values over there, right? So that is exactly it will be done over there. Now see, now this is a sine square and cos square, and that exactly is equals to 1. Sorry, not here. Now that is exactly equals to 1. That is, you write it as expression, comma. You can write it as there. Just take a value which is equals to 1. So this will print this cos sine square theta sine theta square plus cos theta square is equals to 1. Alright. So if you write ex b, so that will again print it kind of sine square theta plus cos square theta equals to 1. Okay. But instead of getting it like this, if I want it to be a whole equation, if I want a square a plus b whole square equals to a square plus b square plus 2ab, like that, right? So how to write those things? So see, for that what I'll do, it's I'm writing from a and b, and in place of all these things, so I'll be writing here these statements. So now my expression, right, is now my ab square, I'm taking a plus b whole square, so my expression will, let it be a underscore of b, let it be an expression. So my expression will be now a plus b whole square, let it be. Alright, so a plus b whole square I am taking, and if I run this one expression, let's say I'm running this, so I'll be getting a plus b whole square there, right? Understood? So I'll be getting there a plus b whole square. Now that probably can be equals to the value we have done here, that like kind of x square plus these all the things. You can just write on these things and just place them over here. AB is not defined there, so you can define that. Okay, meanwhile, don't take it there. You can define it kind of multiplication. So you're getting a square plus 2 square plus b square. Understood? So these are the things I mean to say there, right? So meanwhile, you can use your subs there. That kind of, yes. Anyone there?
Excuse me, sir.
Yes.
So around 124, why are we giving again expression?
124 here.
Yeah, there. Yes, sir.
I'm just taking this one. I have taken a plus b whole square inside this x variable. So I'm just printing this x1. So that is the value.
Sir, can't we get directly from this step, from 123 step, can't we get directly the answer?
That you will be getting out there.
Okay.
Okay, but still I'm just taking it in the variable and then I'll just printing it. Okay.
Okay, sir.
So you can get it directly as see I've done here. I've gotten directly their values. Okay, if you want the coding of this, just right click over here and then click on math ML code or text code or math settings. You can just zoom on the trigger. Zoom factor depends on you. You want 133% or anything. If you want to just zoom the values, if you can't see it, 300%. So these things, you want to see the codes of that. So it will show you the code, how it is the code written there. So math module, and then it's displayed true and all these things.
Okay, sir.
All right.
Thank you, sir.
Welcome. All right. So if I run this one, ex1, and for that I have to store these things in the ex1. Let's see. So let's create an ex1 that will be an ex dot b subs of b plus a plus b. So that there, if you run this, you will be getting your value as 2a plus b square. Now why it is 2a plus b square? Anyone can let me know why it is 2a plus b square? Yes.
So we have replaced b with a plus b.
So you have replaced b plus
with a plus b because
b.
sub function is there.
So
would have
if you
replace a
plus
b.
All right. So you have replaced there b as for the a plus b, exactly correct.
B as a plus b, then it will.
So that will be your 2a. So exactly your a plus a, that is your 2a plus b square. You will be getting both those things, right? So yeah, that is exactly correct. So you can replace this expression with a sub expression over there if you write expression there. Okay, so you can get it there. Meanwhile, you can use any other function to just simplify the values. All right. Suppose you are just taking an expression and you are writing it as kind of, let's take it. So what this stands for, that x square plus 3 into x plus 2. Okay. Now let's take, these are the expressions. So this will be I'll be using simplify. This is my simplify of E. That's all. So now my E1 would be looking like 3x square plus 3x plus 2. It's a polynomial function, right? Kind of, right? So I say that these depends how you write. So if you write it kind of simplify of, so it says it's invalid. Sorry, a lot have been there. Yet. So you can probably over there simplify, capital S is written, simplify. So why it is not taking on? Again problem. Simplify of expression could not pass, failed because an exception being raised. Syntax error of invalid syntax in the line number of 1. SYMPIFY. Maybe because of the phrases. Alright. It's fine. So let's say just simplifying a fraction over there. Let's write it's kind of simplify. Let it be 3 by 2 or plus, let's take it 1 upon 5, 10 upon 5. And these are kind of an expression I want. So I'll be getting 3 plus 2 and these things. Now here the simplify function particularly takes the arguments. Now these are my arguments, that is one my expression and then my evaluate. Okay, so this evaluate, if it is set to false, this arithmetic operators will be converted into the equivalents of the Sympy, right? So if you write it true, you will be getting some kind of things. If you write it like, if you do your experiment and if you write true there, so it will be just a answer. Okay, and if you write it kind of a false, so I don't want to simplify it, I just want to get an expression of that, so I'm getting an expression. Okay, these are the things which stand for getting all the basic functionalities, right? Now let's take just a user is saying I want to calculate the area of a circle. So that's good. Tell him that you are coming in the same good place. You just want to calculate the area of a function. So that's nice. Just give me an input. Enter radius. All right. So just give me the input. What is the radius? He says my radius is 50.5. That's a good radius. All right. Probably the area would be a good one. So it's 50.5. Its radius is there. Okay. So I'll be saying I can calculate in two of the methods. How? I can just find out the square of that and just kind of print the pi r square. So that can be done from math. Import pi, and then you can just print on pi into r square, and you will be getting the values, right? That can be done using this method, and there is some different method just to print it on, right? So you can use the Sympy. You will get again the value, that is your pi and 41410.5. Okay, so that is exactly sorry, this is the, you can represent that as your r square radius, particularly r square into the pi, that is 2550.25 pi is the answer. So it's kind of a representation you can do, right? So for getting that, what is a pi? What is the formula of calculating the circle? So you will be saying that I'll be using the circle formula. It's kind of pi r square. Now that can be a kind, you if you write it like pi r square, so you'll be saying it's Sympy dot the ABC, and you would be importing r from there, right? And then you're writing expression as your pi into the r, and then for the square, sorry. So in place of the value, you'll be giving the evaluations there. So that's you will be printing your expression and then your expr. That's right. That's expr. So you'll be getting your values over there. So if you run this, you'll be getting it's 3.159 something. That is your pi value and then the r square. So you need to define what is your r in place of your, say let's the user has given your r 50.5. So you will be writing the 50.5. Alright, so 50.5 square. So then you run your expression and you will be getting the value similar as the first one. That is right. So that is the thing.
Hello, sir.
Yes.
So importing evidence Sympy is needed or what?
No.
Whenever we use Sympy?
No. I say better to just import Sympy as s and that let it be s dot something or anything in place of using Sympy dot pi.
No.
So just
actually here you have given Sympy dot pi you have given, right? I have given the same, but it asked me that Sympy is not defined. So again I have done it importing Sympy, then the error has been reduced. So I'm asking you, every time whenever you use Sympy, it is needed to import Sympy or what?
No, not exactly. It's not needed. See, I have done it s dot pi. Now I'll be using s in place of Sympy every time. It's not needed for every time. Okay, so once you have imported Sympy, you have imported everything from there. Just you can use there. It's kind of R. So R will be that's X. That will represent. Let it be. So it's B. I. I is not defined. So I you need to define there. Okay. Something some might cannot be defined. So that can be defined like that. Okay. So you can use it in place of the S now. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Okay. So just an expression can be evaluated using the sub-expressions also, as I said. Now let's say you want to find an expression and let's say you have A and B. You want to find the AB, let's say A by B, and you are saying to evaluate the fraction and you are saying it's 20. So 20 digit of precision or define you if you want 10 digit of while you working on what is 10 and 20 I'll define you what it exactly is. So subs is equals to that is sorry caps lock so subs is actually your sub expressions which are equals to kind of you just define your A that is let's say you are dividing A as 50 divided by some values. Now you need to define your values. Let's say you're dividing a 50 by 25. Alright. So you're dividing this, so you'll be getting 0.04a. Right. That is 0.04a, but why a is coming on? Let's see. Invalid. Okay. So yeah, now it's correct. It's 2.0. So define the variable and just write down the expression and then you just get it. So we are saying that 10. Now these 10, why it's not 10 or something like that coming there. I want now, let's say that I am dividing 100 by this 3. So I'll be getting just the outputs as the 10 there. That is a 1, 2, 3. If I, let me zoom there more. So you'll be getting 1, 2, okay, let it wait. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the 9 and this one 10. So total 10 outputs, total 10 characters you are getting. Now if you write it kind of 50, so we're getting 50 characters because these is something which is terminating kind of okay. So you'll be getting these values. So this never ends on right guys. So you'll be getting these values. So if you write the number of letters or something, write 5 over there, you'll be getting a less value of that. Okay, that is how it is representations of all these things. Okay. Now yes, these can be used with the NumPy or the NumPy itself has a lot of things to work on. Okay. So this can be used in many ways to find any logic functions or unlogic functions, not or just to find the true, false, and everything of that, right? The NAND function, NOR function, how it works. So these are the things which work in the Sympy and libraries of all these things, right? You can find just a algebraic expression, a complex function, composite, and all these things there. Okay. So let's deal with some different topics now. Yes. Now let's try to understand the expand function, how the expand things works on, right? So before going to that, just we using the simplify. Till now we have used the, see the difference, we have used the, now still we have used the simplify, right? That is for you the expression showing for you, right? Now we are going to use the simplify, right? So let's say now we have alpha and beta over there, or alpha or gamma, whatever you want. So we have those things, right? Now I just want to simplify an expression. So I'll be writing as simplify, and I want theta square let it be, I want to simplify of first. Let's write an equation over there. So my equation is sin theta multiplied by sin theta. This is my equation. Similarly, I can just take, so just let's take on its square of that. So I just want to just simplify the equation. Let's see, it's sin square theta plus cos square theta is equals to 1, right? Is the correct value. So in place, if I use gamma, so I'll be getting the expression that sin square theta plus cos square gamma is this equation. But I've used the same angles, so that is the formula, right? Sin square theta plus cos square theta equals to 1. So in this, if you write a formula, you'll be getting a value over there, and if you write it a kind of an expression, so you'll be getting a expression that. Okay. So similarly, you have symbols. You have, when you import symbol, you don't need to then write for the symbols and all these things. Okay. Similarly, you just can write a square. Let it be b square plus your g square. So you might think that does not work. Yeah. Define this as what are d and g. So d square plus g square, depends what you write. Similarly, you can just write on that expand d plus g and d minus g. What is the formula of that? Yeah, let me see whether you know these things or not. What is the formula of d into g and d plus g and d minus g? What is that?
D square minus G square.
Very good. So you got 1000 rupees. Alright. So when the Renanda says g square minus g square, right guys? So be very active. Okay. So these are the basics. Alright. So you can find the expressions. You can just write on the factors for you want the factors, possibly the function factor. When I use factor function, this will return you the polynomials and the factors, which could be irreducible factors, right? Kind of. Let's say I'm writing a factor of. Let's say the equation is my d square and e plus g square. That's it. Or let it be e plus 1. Like that. So I'll be getting d square plus d plus 1. Understood? So these are the things I'll be getting by use the factors over there. Similarly, if I take its kind of a factor, and let's say I am taking it as x, y, and z, and I define it as under the symbols, and these are the x, y, z. Okay. So once I have defined these, let's just bring out the factorization. So you have dealt with factorization. So you don't need to do any factorization. You just pass on a module, and it will be a factorized one, right? So let's say your expression is you are taking x square into the z. So x square z, why it is not working? So x square z square plus let it be 4 multiplied by x multiplied by y multiplied by z, okay, plus let it be 4 into z into y square. Alright, so this is my expression particularly now. So if I print my expression, what is my expression? See guys, it's x squared z plus 4 xyz plus 4y squared z. Now if I need to factorize it, what I'll do is, now let's just factorize these things. Yeah, so z will be the common, z will be the common, then you will be left with there as the x square, then okay, then it would be kind of 4xy, and then it will be 4yz. Can this be more factorized? The y square only. So from there, can it will be more factorized? Yes, guys, looking for you. What you say?
X plus 2y.
Yes, someone is saying yes.
So we got 2y is equal to z into x plus 2y whole square.
X plus 2y whole square.
X plus 2y whole square. Okay, that's exactly correct. So we'll be writing with these things. So in just instead of writing all these things, what we do is we'll just pass a factor. That's probably factor of all that. Where is the factor? Okay, just write the factor. Z into x plus 2y whole square exactly. So okay. So now we need the factor one, right? So we'll just write the factor of this particular equation, what we have got. So I'll be getting the value, that is the x into z, x plus 2y whole square. This is as simple you can see now, right? So these are the things we deal with the Sympy, right? So for anything you write, you will be getting a factorization. Now, how it has factorized this, so for getting those things, if you want to factor, how it has factorized on what basis, so you're writing factor terms of the ex. So it says z common, and then it has taken x square, and then it has made a factor of all these things. So more information if you want, so we're writing a factor of just a factor list, how many factor, what the elements you have taken a factor, so you just pass on. It says 1 is there, and z1 and x plus 2y plus 4, and these kind of the things it has been factorized. Okay, so that is why it is for used as a very mathematical things to work on. Understood? So just like a polynomial you can write on, and then you can just work with a polynomial. Okay, so now we're looking for the correct function, right, for the correct one. So that is, this was an kind of factor, so let me write it here. This was the use of factor, and we'll be doing now the collect. Alright, so yeah, so what collect will do, this will just give you the additive terms of the expression. Okay, so let's say your expression is kind of, let me just zoom this one. Let's say your expression is a kind of x multiplied by y, and x minus 3 plus 2 into x into y, and that can be any kind of thing, x, y. Let's take any kind of situation. What is x plus x cube plus y cube plus 3? Okay, let it be x cube plus y cube plus 3x y x. Okay, you have these things. Symbol error. What is? Symbol object is not callable. All right. Mm-hmm. Fine. Okay. Let's see. All right. So you can see knots again. So you can see it's x cube minus x square z plus 2x square plus xy plus x minus 3. Okay. So you can see now, as far as the you know the terms of the powers, so x cube will be coming first, then the x square expression, then the 2x square, then xy, then x, and then the 3. This is basic polynomial equation, right? So we have these things now. Now if I add collect to this, then the function would result you like if I just pass on this expression and I just print it. Okay, I'll give some values over there once again. So if I just pass it on here, so it will just make just a kind of powers exponents equals just a term of an expression with respect to the list, basically. Okay, so what it does, it gives a snippet of all the things. If you write with the respect of x, so it will be just kind of these things, just make a factorization and addition of all these things. So similarly, if you just to go for the correction of the ax by the y, so you'll be getting some of these things. Pieces of your y, yeah. So y is not enough there to work on. Similarly, so you get the on the basis of the x. So if you write on the basis of x, you will be getting there. In place of x, if I write all these things to be y, let's take it there. Let's take it y, make it y, make it x, make it y, make it y, y, y. So if you just run on this first one, so you'll be seeing that it is x, y, or just print the ax first. So let's cut it down. This is a lengthy equation now. So you can see ex is xy plus y cube plus or minus x square z, and then these are the y in place of x now. So if I run this with the respect of the y, so you'll be getting a probably an equation as compared to the xy there, right? So this is what it does. Similarly, you have a lot of for the cancel one. What's the time? Okay, right. So you can done. No. Similarly, you have cancel to work on. What it does basically. Let me write it for this. So this will take a function of any rational function basically, and will put it into the standard canonical form like of a p by q, and where your p and q can be expanded as a polynomials, and they have some no common factors, right? So if I write it like, let it be ex, no inspections. So let it be ex equals x square plus, my power function has been now stopped working, I think.
Sir, your voice is not clear.